Anyone wondering why I have two microphones? It's not because I'm going to speak twice as loud. It was very well thought out redundancy. Good morning, everyone. I'm going to talk about climate. And I'm going to talk specifically about the opportunities at the frontier of climate positive growth. We're here at a technology conference in Nairobi, talking about the potential of technology in different ways. I see innovators, I see investors, I see enablers. And we're living in a very complicated moment. If I'm looking around, I'm seeing a lot of stressed out people. And so I will try and give you a sense of why I am excited about climate and climate technology as one of the biggest opportunities to both create value and transform lives that's available to us today. I will make the argument that we are lucky to be in this moment, in this location on the planet at this moment. And hopefully, I will leave you all with a few ideas on how to think about technology, not narrowly defined. For a long time, I know tech in Africa was confined to bits, not atoms. It was all about the latest and new fintech. But that the broader definition of technological innovation on the continent is a space where the climate battle for the planet will be won or lost. So let's go in. And by the way, just by way of a little bit of context, I've spent 20-something years, more than 20, very kind, struggling with the question of how do you create jobs and economic opportunity on the continent. And 5 years ago, I became convinced that the big opportunity facing us was in the climate space. And so what we're doing now is investing in and building a generation of companies that we believe have the potential to be world leaders in aspects of the global economy that will only grow as we respond to the climate crisis. So that's who I am, where I'm coming from, what Africa Climate Ventures is. Let's get into the meat of the conversation. Or not. There we go. When we talk about the climate in Africa, many of you who may have heard me talk about this before will have heard me allude to the fact that very often our conversation about climate in Africa is about her, right? She is a farmer, a woman trying to raise a family affected by climate change. That does not look like a fertile and green landscape behind her, trying to eke out a living in the hot sun, facing climatic conditions that she did not create, but she is bearing the brunt of. And the conversation ends up being about what do we need to do for her to address her challenges because the rest of the world has prospered from emitting and fossil fuels, leaving her behind. The villagers on near the Lake Turkana wind farm are another example that you just saw. There's a whole range of these images out there. And they are correct, they are true, they are a part of the story. It is not the part of the story that I'll be most focused on today. Because I think there's a different part of the story and a different way to think about Africa in the climate discussion that is sometimes overpowered by the narrative of Africa not causing climate change and bearing the brunt of it. And that is the fact that Africa is crucial to any realistic chance the world has of staying within manageable bounds for the climate. Right? If you read all the scientific reports, we need to do three things as a human species this century. In the 21st century, we need to do three things if we're going to get to the 22nd century. The first one is we need to preserve and expand natural carbon sinks. This one, no one has any trouble seeing how it affects Africa. We have the Congo Basin, we have all of this preserved land and so on. People think, Africa, nature, right? So we need to do that. It's a crucial part of what needs to be done. Protecting and expanding our natural carbon sinks requires a lot of innovation in things like sensing architecture, in things like tracking in the MRV and so on and so forth. It requires a whole new workforce that's tailored towards preserving and expanding biodiversity. Lots of opportunities there. I usually in these talks tend not to spend time on this, not because it's not important, but because this one I suspect people know. So that's the first thing we need to do. It is a non-negotiable part of getting to the 22nd century. The second thing we need to do is we need to take carbon emissions out of every single part of global production and consumption. The part that people think about most is we need to get rid of fossil fuels in transportation. These are some cars parked. I'm going to go ahead and guess that's China. It's the pivot in the nature of mobility, right? Renewably powered, electrically driven. But that same transition needs to happen in almost every sector you can think of. We need to take emissions out of agriculture. Something like 15% of global emissions are in ag. We need to take emissions out of power generation. We need to take emissions out of construction, right? Concrete, steel, cement and steel, huge drivers of global emissions. So in every sector of global industry, we need to reduce emissions. This one, people tend to say, well, what does Africa have to do with that? We are less than 4% of global industrial production. Surely we're not a part of the problem. We're a similar percentage of global mobility emissions because we don't have that many cars. We're not a big part of the solution. What that ignores is, A, there's going to be a lot more of us by the end of this century than there are now. B, our emissions grow as our economies grow, potentially. And C, Africa, because of our endowments, our large labor force, our natural resources, and our vast renewable energy potential, should be the natural green manufacturing capital of the world, right? If you think about where we are heading, as solar prices come down, as other renewable prices come down, the cheapest green kilowatt increasingly becomes the cheapest kilowatt or kilowatt hour. We're seeing this happen in China, where the cheapest power is increasingly renewable power. They still have a lot of coal, but you can see energy-hungry industries in China, as they are the first to feel the wave of this impact, moving towards places where there is a lot of abundant renewable energy. Some of that is because of climate. Some of it is just about a cost advantage. And so what would you do if I told you that I had found a place in the world that had the cheapest energy, the largest labor force, the largest reserves of natural resources? You'd probably say, well, maybe I need to do more manufacturing there. And I think that is a big untold story of the opportunity for Africa. Another part of it, of course, is in the fact that we've got these billions of consumers coming on stream, and we haven't yet committed to a fossil fuel intensive pathway. So what do I mean by that? I mean that shifting to an all-electric boda fleet is much easier when bodas are still on the upswing than once they're established and you have to retire an existing infrastructure. It means that I suspect that in a range of sectors, the leap to e-mobility, to green construction, and so on will be faster in Africa because we haven't built the large old-school cement plants yet. We haven't built the amount of steel production we're going to need. And so a leapfrog, particularly to cost-competitive technologies, makes a lot of sense, right? So keep that in mind, because part of my argument for how we take Africa out of poverty and to middle income status and beyond is saying that we are uniquely positioned to be an industrial powerhouse in a greener industrial planet. Now, some of you will be shaking your heads and saying, have you been reading the newspapers lately? No one is interested in going green right now. And I would say it doesn't matter. It actually doesn't matter. Because as you look at the technology trajectories, the cheaper technologies increasingly are the low emissions technology. Not in every place, not even in most places yet, but you can see some things are declining in cost very fast, and other things are the way they've always been because they hit their actual true costs a long time ago. Those lines will cross. And at that point, like I said, the cheapest green option becomes the cheapest option, period. We can talk about examples later. The third piece of our homework, so the first piece was preserve the green, right? The second piece was stop making the mess. The third piece is clean up your room, right? The third piece is we are probably going to have to remove tens of billions, if not of hundreds of billions of tons of greenhouse gases from the atmosphere this century if we're going to get to the next century. This picture here is of the Climeworks Mammoth plant in Iceland. It's the world's largest direct air carbon capture plant. It's one form of carbon removal. There are many others. I'll talk about some of the others in the next slides. This is the world's largest right now. The world's largest does about 40,000 tons of carbon per year. For us to have any chance of balancing our carbon accounts, we're going to need to build many thousand times this in carbon removal capacity. I'm going to spend a little bit of time on this one because it tends to be a new space, and I'll talk about some specific examples, because I think that work is work that Africa is uniquely positioned to be globally dominant in, just because of our natural endowments, our positioning, and our people. Right? If you buy what it takes to balance the global climate accounts, then you have to believe that industries like this are going to be some of the world's biggest industries in the second half of this century. And they don't get to be the world's biggest industries in the second half of this century without growing pretty rapidly in the first half of this century. And the natural place for that to happen is arguably Africa. I'll get into some of the logic for that in a moment. But again, another area where bad news in the short term actually underlines the importance of this, because the more you emit, right, the more you delay cutting emissions, the more certain people say, we're going to drill, baby, drill, the bigger the amount, the more messy you make your room, the more cleanup you're going to have to do afterwards. Right? This is a fixed equation. If you need the planet to stay livable, these three things have to happen in varying proportions. If you don't do the middle one, you need to do more of the other two. If you don't do the first two, you need to do that one. If you don't do any of the three, well, it doesn't matter. We won't be around anymore. So why does anyone care? So let's talk about carbon removal. I showed a picture of one form of carbon removal, which is direct air carbon capture. And I'll come back to that in a moment. But we need to remember that there are multiple ways to reliably remove carbon dioxide from the atmosphere. And I want to tell you that a lot of the cutting edge examples of that are already happening, not often like some other part of the world, not even somewhere else in Africa, but within like a 90-minute drive, maybe even a 60-minute drive, depending on how fast you drive from where you're sitting right now, right? One of the most reliable technologies for durably storing away carbon from the atmosphere is one that has been with us, not for 5 years, not for 15 years, not for 100 years, but for 5,000 years. Humans have been making biochar for at least 5,000 years. If anyone is asking what is biochar, ni makaa. It's charcoal, right? It's charcoal that you don't burn, because charcoal that you don't burn is molecularly identical to the coal we took out of the ground and burnt and put into the atmosphere. So if you can find a way to make biochar and to use it in a way that it doesn't go back into the atmosphere, you have successfully removed carbon from the atmosphere. Because how was the carbon captured? It was sucked down by photosynthesis by plants into the ground. Long story, the thing you need to remember is some of the most promising applications or deployments of biochar are happening in a very vibrant ecosystem here in Kenya. Multiple companies doing it. I've picked one, not just because I'm invested in them, but because I think they're very cool. And that's Safi Organics, who are doing two things at once. And I think those two things really illustrate the potential opportunity. Actually, they're doing three things. The first thing they're doing is they're taking waste rice husk and turning it into biochar, right? That used to be burnt. It used to, if you've been to the rice growing areas of the country, there's a lot of waste that's being burnt into the atmosphere. You usually have a lot of particulates in the air, a lot of smog. You convert it into biochar, you get rid of that. The next thing they're doing is they're manufacturing a fertilizer using that rice husk and other organic ingredients. Now, that fertilizer has no imported components. It is outperforming, according to a range of scientific tests, it's performing as well or better than chemical fertilizer in the field. And it's entirely homemade. So you're skipping all of the emissions. Every ton of fertilizer you use, every ton of imported fertilizer you use implies between 3 and 4 tons of carbon emissions. So you get rid of those 4 tons. And in addition, the ton of organic fertilizer you're using is putting a ton of carbon back into the ground. So that's a 5-ton swing. A 5-ton swing in our global carbon budget from what we would have used, which would have cost us dollars to import, to what we're making domestically with a labor-intensive process that uses local ingredients and local knowledge, because the actual blended organic nutrients that they're mixing with the biochar are coming from traditional recipes that farmers on this continent have been using for hundreds of years, that are tuned to the local soils and are aligned to local soil needs. So you're doing something better, homegrown, home-informed, and massively scalable. There's something like 500 million tons of waste biomass being burnt in Africa alone every year. 500 million tons. Convert that into biochar, that's a huge dent into global emissions. Not to mention a huge impact on our fertilizer imports and fertilizer-related emissions. That's not the only way we can use our soils to store carbon. This truck is part of a trial we ran a few years ago, of enhanced rock weathering. Another term that I will not spend too much time to explain, just saying it's crushing particular rocks that absorb, I said locks, you heard me, rocks that absorb carbon from the air and spreading them onto land. The beauty of it is it's actually good for the soil as well. It addresses soil acidity while removing carbon. The economics of this are not yet as clear as they are for biochar, but it is equally clear that Africa is going to be one of the best places to do this work. So what are you doing? You're reducing soil acidity, boosting yields while removing carbon, and you're creating a whole demand for a category of folks who are really accounting for all of this process and modeling it for different soils across the continent. And then we come to the big fancy machines that we were talking about earlier. The vacuum cleaners that once we've spread as much biochar as we can make, have crushed as much rock as we can, we're probably still going to have a balance in our cleaning the room assignment. And that balance, really, we're going to have to use energy to remove from the atmosphere and reliably store. A critical part of the story of doing that, I think, is going to be the Rift Valley. And why is that? Because the Rift Valley has two things that are going to be critical to doing this work. The first one is a massive supply of energy. We heard from Kenjan about Kenya's energy wealth. You're going to need to use a lot of energy to remove carbon dioxide from the atmosphere. You may be wondering, why on earth would we do it? It's expensive, we should just leave it. When we start hitting 1.5, 1.6, 1.7 degrees of warming, people will start to pay to cool the planet, right? So we have the energy, but just as importantly, we have the storage space. Because the Rift Valley is rich in porous basalt that can absorb carbon dioxide reliably. Companies that are present here, like Sella, like Octavia Carbon, are working on that exact same thesis. Basically saying we have the energy and we have the resource to build plants like the one you saw earlier here. And where does that energy come from? It's important to remember just how unique Africa is right now. Yes, we are energy poor. Yes, individually we lack access to electricity, but we are also energy rich. The combination of Africa's geothermal, wind, solar, and hydro resources is one of the best, if not the best in the world. We just need to figure out how to make them bankable. And my argument is, some of these climate positive arguments are exactly the way that you make these things bankable. Because the path to bankability is linking it to exports. It's showing that we can generate value that you can use in global markets. And that's a challenge for us, is how do we unlock this potential as it's becoming more bankable? The good news is we have all this energy, we have all these pathways, we have the power to do this particular process. This is here's a geothermal plant. You saw the machines earlier. This is a core drilled from a geothermal zone. This one is taken from Iceland, but we have exactly the same kind of geology here. And those gray spots in the core there, that's carbon dioxide converted into a carbonate in the soil or in the ground. That's stored away for 10,000 years, right? If you look at the Rift Valley, conservative estimates suggest that in Kenya alone, there's probably enough space in our porous basalts to store several 100 billion tons of carbon dioxide. That's the Industrial Revolution, or at least most of it, that we can reverse just with the resource we have on the continent. It's not easy. It's going to be expensive as hell. It's going to take a lot of innovation and a lot of steps forward and steps back. But make no mistake, the global fight to actually balance the carbon equation on the planet will be fought, won, or lost here. And these are the people fighting it. Our young engineers, our young innovators, our young business people. Companies looking at everything from how to actually store carbon dioxide in the ground, how to capture it from the atmosphere, and also how to set up the spaces and actually build the relationships among the different actors that convert this resource from potential into reality. And that's the last point I want to leave you with. We have the youngest population on Earth. We have the one growing workforce on the planet. And the planet has a critical, massive task ahead of it. And we need to mobilize our workforce towards that task, not just because it's a responsibility, but because climate change is a crime of the old against the young. Right? The people who will carry the bill are them. So the people who will have to fix it are them. And also the people who will derive an economic benefit from doing so are them. Not grammatical, but let's stick with it. And so the last thing I'll leave you with is my sense of confidence that there's a range of investment opportunities, innovation opportunities, and demand across all of these spaces for new climate-positive growth leaders in different spaces. The question is, will you get on board before it's so obvious that the potential returns are traded away? Thank you.